our next speaker, someone who is one of the earlier ChainSafe employees, the absolutely amazing Elizabeth Binks, who will be presenting Gossamer, a Polkadot journey in Go. Elizabeth, why don't you go ahead and turn on your camera and microphone and join me on the main stage. Hey, Elizabeth, how are you doing today?
Good. How are you, Dustin?
I'm doing well. We have a great audience here today, so I'll leave it to you and enjoy.
Cool. Sounds good. Okay. One second. Okay. Cool. Okay, looks like you guys can see my window. Alrighty. Okay. So, hello everyone. So, today I am going to be talking to you about Gossamer. So, yeah, I'll just get right into it. Okay. So, yeah, hi. I'll introduce myself to start off. So I'm Elizabeth. I'm a software engineer and tech lead at ChainSafe. So I'm the tech lead on the Gossamer project. I've been working at ChainSafe for almost 3 years now. In March, it'll be 3 years. And these are a few of the projects I've worked on in my time. Cool. So I'm going to give a quick intro about Polkadot. So first of all, what is Polkadot and why did we choose Polkadot? So Polkadot is an interoperability protocol, first of all. So its main goals are to have interoperability and shared security between various chains that execute different state transitions. So as you can kind of see in this diagram, this is sort of a high-level picture of the system. So we have the relay chain in the middle and then the parachains on the sides. So another goal of Polkadot is to have forkless upgrades, so to be able to update the runtime of the chain without needing to fork or upgrade your node. So this is in contrast to Ethereum or some other networks where you have to fork the network to upgrade. And if you would like more information on Polkadot, you can see the Polkadot light paper in their documentation. It's a good overview of everything. Cool. So a little bit about Gossamer. So we got a grant from the Web3 Foundation last January in 2019 to build the Polkadot runtime environment in Go, as it was called at the time. So Polkadot runtime environment has since been renamed to the Polkadot host. They're the same thing, just renamed. So ever since then, I've been working on Gossamer, which is the Polkadot host implementation in Go. So you're probably asking, what's the Polkadot host? So that's a good question. So you've probably heard of Substrate. So Substrate is the original implementation of a Polkadot host. So the idea with the Polkadot host is that it's a blockchain framework for building your own blockchain. And in addition to that, it's compatible with the Polkadot network. So Substrate is the framework, and then Polkadot is the actual protocol that the network runs. And then Substrate has also been used to build other Polkadot networks like Gossamer and the testnets. So Gossamer provides the same functionality as Substrate, or ideally it will very soon, but except it's implemented in Go instead of Rust. So and if you would like more information on Substrate, there's a really good talk by Gavin Wood at the Web3 Summit 2018 called Substrate, a Rustic Vision for Polkadot. So I'd recommend watching that. Cool. So I'm just gonna give a Gossamer update. So our primary goal for Gossamer at this point is interoperability with Gossamer and Polkadot. So we're getting very close in terms of compatibility. So we've recently upgraded to the v0.8 runtime. I'll explain a little bit more what this means in the following slides, but essentially it means that the API for the runtime matches now. with other networks. And then our in parallel goal to that is to have Polkadot.js support for Gossamer. So this would allow users to easily interact with the node, manage their accounts, and submit extrinsics, and just monitor the network in general. And then we're also working on updating, also related to interoperability, is updating the networking protocols that we can sync with Gossamer and Polkadot, because it's recently been upgraded. And then as well as just internally testing the Gossamer nodes so that they can stay synced and continue to finalize under various conditions. Cool. So yeah, so a runtime. So one of the most interesting and challenging parts, I would say, of Gossamer is the runtime. So the runtime is the state transition logic of the chain. So as you can kind of see from this little picture, the block represents one transition, I suppose. Well, the transition is, yes, so how a block is created is determined by the transition function, as well as what transactions are valid to be included in that block. Okay, so yeah, so the Polkadot host is essentially everything around the runtime that allows it to become a blockchain. So everything except the actual runtime itself is the host. So the things like networking, the storage tree, databases, all that kind of stuff. That's what the host is. All the things that are used by all blockchains. So what is the kind of design decision for building the host in this way? So like I said earlier, one of the reasons is so you can upgrade without forks. So this allows for on-chain governance, so you can submit votes to the network to upgrade the actual state transition of the chain itself. So the runtime is just a binary that's stored in the storage tree, so it can easily be changed at any time. And as well, the other design decision is to have a standard interface for the runtime so that people can easily implement their own custom chain. So like I said earlier, the WASM, so runtime is just a WebAssembly or WASM blob that's executed via some interpreter that's in the host. So it's sandboxed from the rest of the code. And then it doesn't store any node data. It just deals only with the state transition logic. It doesn't store anything like the storage, keys, anything else it needs. It gets that from the host, which I'll explain a little bit more in the following slides. So Gossamer currently has support for two different WASM interpreters. Wasmer, sorry, the slide isn't great, but Wasmer and Wasmtime. So why? So these two perform the same functionality, which is interpreting WASM code. So currently it has support for both because we want to eventually benchmark the two of them, see which one's more efficient, as well as determining eventually which is more maintainable for us, which has an easier Go API to use. So using Gossamer. So if you would like to make your own Gossamer chain, what do you have to do? So the main thing is putting in your runtime. So if you look here in the Genesis file, there's a section of the Genesis file called system code. And this is where the runtime code at Genesis is stored. So when you launch your chain, it launches the chain with whatever code is stored in this system code key. So if you want to make your own custom chain, you need to have your own custom runtime, first of all. It has to be compiled to a WASM binary. And then once you've done that, you can simply throw it into this Genesis field system code and then hit run, and everything should work. Yeah, as long as the API matches. So what is this API I've been talking about? So from the Go side of things, the runtime consists of specific API functions. So the runtime needs to expose these functions so that the host can call into them. So this interface here that you see is the interface that Gossamer uses to interact with the runtime. So the functionality of the runtime is to do with block production as well as block and transaction validation. So, and then there's also a few functions for configurations that have some constants stored in them. So the first 4 functions here are to do with, configuration options. And then the one after that, validate transaction, is for validating incoming transactions before you include it in a block. And then the next 4 functions, from initialize block to finalize block, are used to actually build a block. And then the last one, execute block, is used to verify a block that you've received from someone else. So at specific points in Gossamer's execution, it'll call into these functions whenever it needs. So yeah, that's essentially the API. So as long as the runtime matches these functions, or matches the API, exposes these functions, it is good to go. Cool. So what's kind of inside the runtime? So a runtime, you can build it either yourself in whatever language that can compile to WASM. You just have to implement the API that I showed in the previous slide. Or you could use Frame, framework for runtime aggregation of modularized entities. So this is a domain-specific language for building runtimes, also written by Parity, and it's written using Rust and can be compiled to WASM. So the runtime is, if you use Frame, is composed of modules called palettes that have specific functionality that you potentially would like in your chain. So a lot of them are just common sort of features that you would like in a chain. So like value transfers, like tokens, perhaps. There's also stuff to do with smart contracting, EVM support, and there's also stuff to do with consensus, so Babe and Grandpa, as well as on-chain governance. So you have staking, which is super, super important, as well as other governance things like I see treasury, elections, democracy, that kind of thing. So the idea with palettes is that it's easy to just plug these into your runtime, just like pick and choose what you need, as well as if you want to make your own custom palette, you can easily do that as well. Yeah, but then you wouldn't have to worry about the more basic things like value transfers. You can just plug those in. Cool. And then also, I don't know if you guys can really see from this picture, but there's a support library that easily turns the modules into the API. So cool. Okay, so what does Gossamer look like from the runtime? So while the runtime is executing, it's able to access certain Go functionality that it needs via some functions that are imported into the runtime instance. So the reason for this is because like I said earlier, the runtime is just a binary that just has the state transition logic. It doesn't have anything stored in it. So it has to access the storage tree, which is located in the host. So to do this, the functions that are imported into imported into the runtime instance can all access this context struct. So the context contains an interface for the storage, as well as allocator for managing memory, the key store for signing, and then a few other, the rest are mainly just constants for letting the runtime know what the state of the node is. So the storage is the main one that's used. So the runtime is essentially the only part of the host that modifies the storage tree. So while it's doing some either block building or syncing a block from someone else, it'll be updating the storage tree to update whatever values are needed, as well as get whatever values are needed, delete any values. So the runtime essentially does all the storage tree management for you. And then the storage tree is just a modified Merkle persistor tree, similar to Ethereum, so not exactly the same, but similar idea. Cool. Okay, so why is all of this interesting? So this makes the runtime really modular. So essentially, as long as the API stays the same, the runtime can change with as much as it wants without any changes to the node. So like I said earlier, this lets you have governance, upgrades without forking, that kind of thing. So so Gossamer runtime updates mostly consist of updating the host to work with a newer API. So generally, when the API changes, the core functionality stays the same. The main changes are maybe a few new functions or renamed functions or different parameters, like that kind of thing. As well as the imported Go functions might be potentially different. Cool. Okay. So what are kind of the next steps for Gossamer? So like I said earlier, one of them is Polkadot.js support. To allow for easy user interactions. And then kind of alongside that, we'd like to build a Go extrinsics library to allow for extrinsics to easily be formed and submitted on the Go side, because right now all the tooling is in Rust or JavaScript. And then as well, since we have updated the runtime, we would like to try syncing with the different networks. So the main ones would be Polkadot and Gossamer, and then also just a local substrate node, just to make sure that everything works with that. So the main kind of blockers here are just the networking protocols. So stuff like message encoding, potential like the stream protocols, that kind of thing. And then another next step is to just run a Gossamer only testnet. This can kind of be done in parallel with the interoperability stuff. So this is kind of just to test that the functionality is consistent within Gossamer nodes. So to make sure that finality continues to work, the network doesn't fork, changes to the epochs and the authorities, the runtime and such are propagated correctly. And then as well to test under various network conditions, make sure all of that stuff still works. So at the Gossamer testnet stage, essentially users should be able to play around with the node, join the testnet hopefully. And then as well as at that point, they'd be able to try their own Gossamer chain. So if you have perhaps an existing runtime or you want to just make one, you can try to plug that into Gossamer and see what happens. Cool. Okay, so that's essentially it. So thanks for watching. If you would like to check out the code, you can check it out on the ChainSafe GitHub. We also have some docs up at gossamer.chainsafe.io. And you can also contact me if you'd like at my email, elizabeth@chainsafe.io, or you can also message in the Discord, which is in the Gossamer README. Cool. Okay, thank you. And then hiring slide, because we're hiring. Cool.
Awesome. Thank you so much, Elizabeth. I'm beyond excited for the future of Gossamer and the Polkadot ecosystem. Very exciting stuff. We do have a couple questions for you. And just to let everyone know, there is a Q&A section. Feel free to put your questions there, upvote on particular questions you want answered in priority, and so forth. So the top Q&A question for Elizabeth: what has been the hardest aspect of testing runtimes?
Great question. Okay, so I'd say the main thing is just the fact that the runtime is opaque. Like it's just a WASM binary. You don't really know like what's going on in it. So when you're executing the runtime, you can't really see what's going on internally. You can only see when it's calling into Go functions. That's like, but then between that, you don't know what's happening. So sometimes if you have like potentially wrong encoding or some wrong data, it's really hard to know like what is wrong about it and like how it's internally calculating and decoding it. Like sometimes you can try looking at the Rust code to see what it's doing, but like I said earlier, it's written with frame for the most part. So then there's a lot of like layers that sort of wrap it. So even when you're looking at the substrate code, it'll say like, oh, it calls like system whatever key it wants, and then but then when it gets compiled to WASM, that completely changes and it turns into various other operations. So it's hard to know exactly what it's doing. So it's mostly, yeah, so I'd say the hardest aspect is just like getting the data to encode properly, getting it all to decode properly inside the WASM binary, that kind of thing.
Awesome. Thank you so much. Our next top question, does this mean I won't need to know Rust to work with substrate blockchains?
Correct. Yes. So you won't need to know Rust. So Gossamer, yes, pure Go. Everything's Go. So I guess the only Rust you would need to know, it's not even so much Rust, but just to build your own runtime, you would need to use something that would compile to WASM, which is Frame so it would probably be Frame, which is Rust-esque. So but you wouldn't need to know Rust to work with substrate blockchains.
Awesome. Thank you so much. Another question, what has been the most challenging aspect to building Gossamer?
Okay, another great question. So the runtime has been definitely one of the most challenging, just because, like I said, it's super opaque, as well as there aren't any pure Go WASM interpreters as far as I know. So sometimes you have to deal with some funny things happening. Mostly uses like CGO behind the scenes, as well just dealing with like a lot of spec changes. So at a higher level, just I don't know. Sometimes you'll implement something and the spec changes and you have to go re-implement it, and takes twice as long as you expect it to take, and that kind of thing. So mostly, technically probably the runtime, and then just in general, just spec changes, trying to keep up with substrate, that kind of thing.
Awesome. Our last question for you: why do we need a Go implementation of this?
Great question. So every sort of network needs multiple implementations of the protocol for many reasons, but the main one is just that if there's a vulnerability or some issue in one of the implementations, hopefully the other implementations won't also have that issue. So this has been demonstrated on Ethereum a few times. So just essentially having a more robust network with many implementations of the protocols.
Awesome. Let's get a clapping emojis to Elizabeth. Elizabeth, thank you so much for your time and the great presentation.
Cool. Thank you so much.
Awesome. Go ahead and unshare your screen, and thank you so much.
Yeah, thank you, Dustin. Okay, bye, everyone.